Good afternoon. I'm delighted to see a pretty full house this afternoon. Special day, as you can see, for us to be celebrating the investiture of Suzanne Brady Calney as the Sally S. Morley Designated Professor in Brain Tumor Research, and Xin Qi as the Jeanette M. and Joseph S. Silber Professor for the study of brain science. Those are big mouthfuls, and you'll be appreciative of the fact that they're filled by very impressive individuals. I'd also like to thank the large families of Suzanne Brady Calney and Dr. C. I don't think that they match the numbers, but I'm delighted to see. I think we took the largest picture for the Brady and Calney family this afternoon. I'd also like to note John Morley's son Tom and his wife Kelly are here, carrying on the tradition and the importance of our legacy of our professorships and the importance and contributions that the Morley family has made both to Case Western and to university hospitals. I'd like to acknowledge that Dan Simon here is president of Academic and External Affairs and Chief Scientific Officer at University Hospitals. It certainly is an honor. One of the most fun things in my job is to both pronounce and oversee the investiture of the extraordinary faculty who we are able to select as holders of our endowed professorships. They certainly honor our best and our brightest faculty and recognize the contributions that they make to the school, to the city, and to human health. Obviously, endowed professorships give us a special boost to those individuals as well as the departments that they represent. Now, what in the world is a professorship? So those of you who heard this story, I change it a little bit every time, so it's not old. Those of you who haven't, I hope it helps you appreciate the incredible nature of endowed professorships. So they go back to the Renaissance, when King Henry VIII, who was known for many things, but in 1540 he founded the Regis Chair of Civil Law at Oxford University. In the United States, endowed professorships go back to Harvard's Hollis Professorship in Mathematics and Natural Philosophy, established in 1721. It's now in the Divinity School at Harvard. And like all professorships, there's been a sequence of individuals. It's now held by Karen King. I'm not sure that Dr. Hollis would have imagined that a woman would be holding the chair, and I'm glad we're at that point. Our school's endowed professorships go back about 120 years or so, starting with the Hanna family. The Leonard C. Hanna Professorship was established in 1901, and that was a gift of Howard Hanna in honor of his father, and many of you probably have a home that you purchased from the Howard Hanna disciples. Next came the Henry Wilson Payne Professorship in Anatomy in 1903, was also a gift of Howard Hanna. And then in 1906 was the Hanna Payne Professorship in Experimental Medicine, a joint gift from the Howard Hanna and Oliver Payne family. So those professorships have been important for the school over decades and allow us to really carry forward. We now have 125 endowed professorships. So what I have been impressed with, and the two efforts that we'll hear about today in brain health and brain disease, these are really fundamental issues in our world, in our lifetimes, and will forever be prominent in our research, therapeutics, and education. So let me tell you about the Sally S. Morley Designated Professor in Brain Tumor Research. It was established in 2016 by John Morley in honor of his wife Sally, who passed away in 2014 after a courageous battle with a brain tumor. John passed away just a few years ago in 2022. John and Sally met while students at Yale and at Smith. shared 26 years of marriage and adventured 66 years of marriage together, raising 6 sons. We only have one here this afternoon, and moving around the country. They settled in Cleveland in 1981 when John was appointed CEO of Reliance Electric, and he served in that capacity till 1995 when it was acquired. He then led an investor group with leverage acquisitions that included interactions with Exxon, which took Reliance public. He was the director of many private and public corporations: Cleveland Cliffs, AMP, Faro, Key Corp, Lansing Sessions, and he served on nonprofits, including the boards of Case Western and University Hospitals, where he served between 1987 and 2005. Back during that period, there were a few members of the boards of both, and John Morley was a key intermediary between our organizations to sort of keep us together. That frayed a little bit, but it's a good idea on the legal side to have people talking to each other, as you can imagine. He also served on the Dean's Visiting Committee, and I met him because he was also part of our Comprehensive Cancer Center Cancer Council. So Sally's life was pretty remarkable as a spouse, mother, 6 children, grandmother, sister, aunt, friend, major contributor in our community, taught elementary school after Smith College, and began a lifelong interest in education, which helped her connect with our School of Medicine. She was on the board of trustees of Ursuline College, a co-founder and director for the Career Initiative Center, and an honorary director and a member of the board of Beach Brook. These are all community activities that we're all aware of here. They were incredibly generous and visionary philanthropists around our community, and obviously the professorship was dearly felt by them and for us. Dr. Suzanne Brady-Cowney was appointed a few years ago as a Sally S. Morley Professor in brain tumor research in 2022, but Dr. Morley's travel and health issues delayed us being able to honor him until today. And of course, we were a little short-circuited by the COVID epidemic. So I'm delighted that Tom and Kelly are here with us this afternoon. I'd love to tell you more about Dr. Suzanne Brady-Cowney, but I'm going to ask Tom to come up and say a few words. So please come up and join me first, and then we'll hear more about Suzanne.
Thanks. Hi, good afternoon. I'm Tom Morley, and I really appreciate being here and appreciate being included. I've been given 5 minutes to just give a couple of thoughts, so I will try to stick to that, and if I don't, at least say something hopefully interesting. I guess I want to start, Dr. Kieran. I have a bachelor's degree in history, and I love history, and so I found it really interesting to learn about the history of chairs, and that the first in America was 1700s at Harvard. And it doesn't surprise me, I guess, if I think back to sort of the inspiration that I've gotten from Mom and Dad over the years. And it today really kind of informs my life. And it's a gift, and so I think it's not a coincidence that this tradition was started so long ago and is present today. And I guess as it relates specifically to Case, Mom and Dad, and Suzanne, I was thinking about just some interesting stories to relate, and this is, I guess, the most pertinent one, is that both Mom and Dad supported these causes, and Mom passed away from a GBM, and I think that was 2014. And that was, when it comes to brain science, it's scary and it's hard, but boy, is it amazing sometimes what you learn and what you same thing with my father's heart. Anyway, she ultimately participated in as much research and clinical study as she could for Dr. Sloan at UH. And that's just the way she was. And so when she passed away and Dad did this chair, it was kind of a natural progression. And it's been great to meet Suzanne, and I'm a small business guy by profession, and so following her and some of the commercialization efforts is just a real privilege to be a part, to even be a fly on the wall for it, frankly. And then I wanted to just quickly say that with Dad, it was the same thing. Sadly, he had Alzheimer's and ultimately lost that struggle. But boy, he ended up funding, participating in, and then donating his brain to the research for Alzheimer's here in Cleveland, and work being done by Andrew Pieper and his memory care, Dr. Brian Appleby, and others. So for me, that just says it all. It's really inspiring, and I hope some of these things will provide some inspiration and motivation for Suzanne and others that are doing some really, really important work. So thanks for listening, and really appreciate being here. Thank you.
So thank you very much for your comments, and I have a little surprise for you for some new ideas that we'll talk about after this event with you and Suzanne and Shane, which I think are actually pretty exciting, moving, as you said, that interface of brain and cancer together. So I'm going to ask Jonathan Karn to come up as the chair of microbiology and the Reinberger Professor of Microbiology. He also directs the Case Center for AIDS Research and is prominent in the AIDS world and in infectious disease worldwide. He's also a member of the Comprehensive Cancer Center and our cancer prevention program. He has been a fundamental leader in HIV research for decades, and is a leader of the current worldwide initiative in HIV cure, an effort to finally rid us of that amazing disorder. Internationally recognized as a molecular virologist, innovative in all aspects of his work, transcriptional control, proliferation, the latent virus, et cetera, and has constantly kept a link between the basic biology of HIV and both therapeutic advances and population studies. He has been absolutely prolific, has had multiple millions of grant research, and I think arguably has the most individual grant research of any of our chairs, so just don't tell any other chairs, but thank you. He's also been a remarkably kind, cool, and responsible mentor for fellows both here and internationally, graduate students, research scientists, and his department. And I think he has been a proud sponsor for Dr. Brady County as well. So without further ado, tell us about Dr. Brady County.
So it's a great pleasure to be here and say a few words about Suzanne. As you can see from this photo, Suzanne's really a dynamo. And, in medicine they talk about triple threats, but she's actually a quadruple threat. She's excelled at teaching, research, service activities in the university, and now she's commercializing everything, so it's an extra string to her bow. And in fact, I found over the years that Suzanne's hard to keep up with. So one of the things I tend to do is just follow her activities in the Case Daily, which I recommend to you highly if you want to follow Suzanne's activities. So here's a notice from 2011 when she received recognition from, not from us, but from the University of Dayton. And I think, I remember she was particularly touched by that because, when your undergraduate school recognizes you, that's really high praise indeed. Suzanne actually predated me here at Case. She was recruited from Cold Spring Harbor in 1995. I came in 2002, and she was still an assistant professor. And one of the first things I thought was, well, why is she still an assistant professor? We better get her promoted. And everyone said, well, it's this long, difficult process, and you have to go through the CAPT committee and all this stuff. It was my first attempt at it, and she sailed right through. And so I thought, well, that's really not a very difficult process. And then I discovered the next time around that actually it was Suzanne that sailed through. Another early achievement of hers, this was 2 years later, where she received a very prestigious grant from the National Cancer Institute. It was a provocative question grant. And I think that title really sums up her research, that she is always asking these very provocative questions. How do you go from a signaling molecule, relate that to a disease, relate that to a diagnostic, and perhaps even in the future relate that to a cure, because the diagnostic is targeting the cells that you want to get after. Now, in those lines, she's made these imaging agents, again, 2022, when, again, there was more information coming out and a large grant to actually start the imaging work that she'll be talking about. Another accolade for Suzanne, of which I think we're all particularly proud, is that she was elected as a senior member of the National Academy of Inventors. So this is, like an Academy of Sciences, extremely prestigious, and recognizing that she's had impact not only in the academic world, but in the broader sphere of commercialization and inventions. So it's been a terrific record. I think the fun is only beginning, and she's going to be able to leverage this additional generous support into new research activities, new research findings, and maybe help really address brain cancers in a new and profound way. So, Suzanne.
Thanks, John, for the kind introduction, and Stan, too. So I thought I'd tell you a little bit about myself and things that most of you probably don't know, but I owe my life to Case Western Reserve University because my parents met here. So my dad came here to do some engineering classes, deciding if he wanted to do a master's degree or not. He's an electrical engineer. And my mom moved here from just outside of Erie, Pennsylvania, because she graduated from college as a teacher, and she came to teach in the Cleveland City Schools at Denison on the near west side. But she moved to Little Italy, so one day they both decided to come to a dance here at the Newman Center, and I guess the rest is history. So my dad then went on, instead of finishing a master's, decided to go to the new NASA, which was just starting near the airport in the early 60s. And he stayed there for 37 years, so you can see why I'm staying in the same place all the time. I come from that background. But I also have a background in medicine because my grandmother and all of her sisters were nurses, and my Uncle Al was an MD, PhD. And so all I wanted as a kid was doctor kits, so I was destined to go this route. And this is their wedding picture there. My mom, Elena, is here we lost my dad 2 years ago to metastatic prostate cancer, but he's shown here on the right. And these are my siblings. So the most important thing in my life has always been my family. And everybody's here today. So my brother Steve, my brother Paul, my sister Kathy, and my sister Christy, and my mom is there in the picture, and they're all here today. So that's why we got the comment about the biggest picture. We've got about 15 people here. So this is the next generation, all the kids, and even a new little one there. And so these are all my nieces and nephews, and they are the highlight of my life, to be spending time with them. And this newest little guy in our family was really intent on looking at his scan. He was fascinated by it. So maybe we have a budding radiologist in the family here. So he's here tonight at the door there, Bo. We also have a huge Italian family, as you can tell, lots of relatives outside of Erie, our Shamera family, Yoris and Kaisers, and then the Brady family down in Florida and North Carolina, and I think a lot of people are online today. So I just want to thank them for their support. So I started out, because my dad was at NASA, we lived in North Olmsted till I was in 6th grade and went to St. Richard's School, and then he decided he doesn't like being around people very much, so he bought a farm out near Oberlin. We started out with 50 acres, and now we have 140 acres there, and that's our vineyard, and we have a winery, which some of you have been to, so that keeps us busy. And I wanted to highlight that I went to a very rural high school called New London High School, and I was so fortunate to have a teacher in 8th grade that was a chemist and a biologist, and he had us do fruit fly genetic crosses in 8th grade, and I was hooked after that, so I never thought about doing anything else. And then I went to the University of Dayton, which is an important place for our family. So my great-grandfather went there, my father, my uncle, my husband, and myself. So UD was very important. I was a biology major, and I worked in Dr. John Rowe's lab for 4 years as an undergraduate, so that helped me think about graduate school. And some of my freshman roommate is here today. Bonnie, thank you. We're lifelong friends, so they paired us well, despite the fact that she's from Pittsburgh and I was from Cleveland, so I don't know how they came up with that. But, and all of my study partners over the years, great friends, lifelong friends, that, and the Rowe brothers that are online today watching me. So the most important thing I think happened at UD was I met my husband, who I was happily married to for 30 years, and unfortunately he died 9 years ago today. So we still miss him, but his family is representing him today. But he was originally a UD computer scientist, got his master's there, and this was like 1985, so that computer science was very new then. But he eventually when we came here to Case Western, he did a law degree here, and then he became a computer patent lawyer. And he had a lot of high-level clients on the West Coast, as you can imagine, in Seattle. But he loved writing patents for Case Western Reserve and all the imaging guys here. And I think he would have done it for free, but luckily they did pay him, so that was good. And his brother, Bart, also wrote a lot of patents here for the university. And our Kelnay family is here today from Canada. They braved the winter to come down and join us here at the ceremony. So thank you guys representing him for us. So to move to the science, I just wanted to show you my scientific family tree here. So I did my PhD at the University of Cincinnati in Bob Brackenberry's lab, and Bob was a postdoc with the Nobel laureate Gerald Edelman. And then I did my postdoctoral fellowship with Nick Tonks at Cold Spring Harbor Labs, and he was a postdoctoral fellow with the Nobel laureates Eddie Fisher and Ed Krebs. So I have a good family tree here in science. And I met and made so many lifelong friends at Cincinnati and at Cold Spring Harbor. And two very special people that have mentored me, Richard and Judy, are online today. So just want to thank them for all their support. I came straight from Cold Spring Harbor here as a new assistant professor 30 years ago. So I've been here a long time, and I was fortunate. I got a few job offers, but this was actually the very best place for me because there were a bunch of cell adhesion experts here at the time. Vance Lemon, Ernst Rudeshauser, Lynn Landmesser, Lloyd Culp, and so it was just this fantastic environment to come to. And we had an expert on receptor tyrosine kinases at the time, and I work on a class of proteins called receptor tyrosine phosphatases, and that was Sinjun Kung. So I felt like I got a great start here. And I'm a professor of molecular biology and microbiology as my primary appointment, but I'm also a professor of neurosciences and pathology, and they have tremendously supported me over the years, and I thank them. Some centers have been extremely important in my career. The Cancer Center, #1. Stan gave me my very first grant when he was directing the ACS, the American Cancer Society program here. And the Center for Imaging Research dominates everything that I have been doing for the past 15 years. The Visual Sciences Research Center and their cores and core managers have been instrumental in us being able to do the work that we've done. Our training programs where I've directed for many years, the CBTP, the BSTP, and participated in a lot of graduate activities, including 50 thesis committees over the years. But this place is dominated by amazing collaborators, colleagues, students, trainees, and staff, and they've all helped me. I thought about trying to list people, and it would have taken days to list how many wonderful people have helped me over the years. Most importantly, of course, is the lab that's put up with me and tolerated me all these years, and I've had a lot of people that have worked for me over 10 years, and I really appreciate everyone that's listed here. And my current lab is shown at the bottom. Meta, Kathy, Cynthia, Samantha, Marissa, and Noreen are currently working in the lab, and they have done all the work that I'm showing you between the past and present. They probably say I don't do anything, so I took a basic science discovery, and I'm trying to translate that into novel ways to recognize tumors, both from an imaging perspective and eventually a therapeutic perspective. So I actually started working on the immunoglobulin superfamily of adhesion molecules 38 years ago. So I haven't strayed at all in those 38 years, and I mostly focused on a protein called PTP-mu. So we discovered that there were fragments of that protein in cancer cells, and we've exploited that discovery to make a series of imaging, drug delivery, and novel therapies. And just to give you a feel for why that's important is in cancer often this current standard of care is you do surgery, you do radiation or chemotherapy, and none of it works very well on invasive and metastatic tumors. And oftentimes up to 90% of the tumor occurs right at the surgical margin. Like if they just could have got a little bit more, maybe you'd have a better prognosis. So we're finding ways to highlight where those surgical margins are, and then other ways to deliver therapeutics there. So people often think that a cancer is a round ball, like shown on the left-hand side of this figure, and it's the furthest thing from the truth. What you actually see is what you see on the right-hand side. So those yellow cells are invading cells that are spreading away from the main tumor mass, crawling on blood vessels, crawling on nerves, and they are not easy for anyone to see, and they're not easy to treat. And that's a figure by Silber and Gully from many years ago. But we now know that cancer is very complex. It's many different cell types. It's different in the primary tumor. It's different when the cells start invading. And it's different when you get to the metastatic site. So you've got to find a way to see the tumor through all of these stages. And we think we've discovered a way to do that. So both, as people mentioned, I've done a lot with tech transfer here and founded a biotech company called NeoIndicate to try to bring some of these discoveries to actual patient care. And so we've worked on a series of in vitro diagnostics where you can take biopsy samples and look at whether it's tumor or normal. We've done a bunch of molecular imaging agents, and we've done targeted drug delivery and novel therapeutics. But this last slide is what we're focused on translating right now. So fluorescence-guided resection is a way, if you could light up those invasive tumor cells and the surgeon could see it in real time, they could cut it out. They could do better at cutting out those margins. So we've developed a way for them to see those tumor cells and then different ways to treat it. So the translational part is actually quite complex, and I have to say I've been doing it for over 15 years now, trying to get this to the clinic. And it requires that you do a bunch of patenting, and which has been facilitated by the Tech Transfer Office and Rich Sutkus at Tiroli. And then that led to me being elected to the National Academy of Inventors, because I have like 12 issued patents and a bunch of pending applications. But the translational programs have been hugely important, like Coulter and Ka and the CTP TVSF program, and then eventually founding NeoIndicate. Our CEO is Ted Gastineau, and Samantha Oblander is our Chief Operating Officer, and Taft helps us with the legal process. So just to speak to the impact of this professorship is that it's allowing me to pursue these new imaging agents, to translate those imaging agents into delivering therapeutics. And our ultimate goal, which we're so close to, is I've been working on filing a clinical trial with Andy Sloan and Tiffany Hodges to do fluorescence-guided resection of glioblastoma. And we're about 2 weeks away from submitting our IND after all these years. So we're really excited about that. And I just want to thank the Morley family for their support. Andy Sloan treated Mrs. Morley, and his wife, Jill Barnholt Sloan, was the first recipient of this chair. And Jill and Andy are longtime collaborators that have helped us immensely. And I just want to, these are just some people from collaborators and staff members that have helped in recent publications, and so many funders that have brought us to this stage. And I just want to thank everyone, especially my family, for being here, and thanks to the university.
For those of you who come to these, you know that I make mistakes occasionally. So. Yes, it is. Okay. So it says, Suzanne Brady-Cowney, PhD, Sally S. Morley, Professor of Brain Tumor Research. So you get to sit in your chair. You can leave the chair. We'll get it. So now it is my pleasure to move on to our second professorship for this afternoon, and that is the Jeanette M. and Sally S. Silber Professorship for the study of brain sciences. Thankfully, that discipline and area isn't ever going to go away. We will be studying that for centuries. In 1999, Jeanette Silber made a commitment to fund a professorship in brain research and contributed the fund until her passing in 2011 at the age of 107. So for those of us in the development business, it took a long time to actually get there, but we were delighted with her incredibly long life and the effort that she made to allow cancer patients to live long lives as well. Now, you may have heard in passing that Dr. Brady-Cowney mentioned that I was involved with her first grant when I headed what was the Jeanette M. Silber pilot grant funding mechanism through the American Cancer Society, so there is in fact a direct connection between these two professorships. She worked tirelessly with the American Cancer Society here in Cuyahoga County, funding its research and some education programs as well. And after her death, her husband, Joseph, who was a national member also of the American Cancer Society, and helped the American Cancer Society establish the Hope Lodge here in Cleveland. He actually visited one at Johns Hopkins and came back and said that we should do one here, and they chose the Little Italy site. Hopefully many of you know where that is, where the Hope Lodge is, to be close to the major medical centers. And each of the major medical centers keeps that place fully occupied with patients that enjoy being able to be out of the hospital but close by for weeks after their treatment. Now, it's undergoing a recent, or just completed a recent expansion, but it started in 1994. During that time, Jeanette made frequent visits, and I know personally that because I would be involved in some of her tours of the facility as it was being built, after it was being built, and then with annual reviews of it. And she was a pretty outspoken person. She was encouraged by the American Cancer Society before they decided on the Cuyahoga site here to think about having it be constructed in Columbus. And I'm going to quote, only because there's a quote that's out there. She said, you know, men don't have much regard for women's brains. They fought me all the way, she said, about building it here. So I'm glad that she did. So in addition, Jeanette was active in the community with the Council of Gardens on Tyler Road. She had an active social engagement, cooking almost weekly at home with the residents that would come, and then tour gardens. She did an awful lot of charitable work. And the family then established the Foundation for Hospice Care, which became the funding for Hope Lodge. So, as you can see, we've had two individuals for these two professorships deeply involved with the area that they were committed to. That interplay, if you will, between cancer and the brain. And in that regard, Dr. Xin Shi, who will be the recipient, is remarkable for her innovative research in mitochondrial control, immune function, and in neurodegeneration. I don't get to tell you too much more about Dr. Xin Shi, but instead I'm going to introduce Dr. Walter Boron, who will do a better job than I, since he, in fact, informed me that the next holder of this professorship would be Xin Shi, so I want to congratulate him on his wise selection. Dr. Bourne himself is Distinguished University Professor and holds the David and Inez Myers Antonio Scarpa Professorship in Physiology. He earned his A.B. in Chemistry at St. Louis University and his MD PhD in Physiology and Biophysics at Washington University in St. Louis. He joined the Yale faculty as a postdoc and then remained there for 29 years, becoming the chair on 3 successive, I think, 5-year terms in the Department of Cellular and Molecular Biology. But he returned to his hometown in Cleveland and joined Case Western Reserve as the chair of biophysics and physiology, where his lab is focused on a longstanding interest in understanding intracellular pH homeostasis and pumps, which is a critical aspect of all of physiology as far as I can tell: cell division, metabolism, channels, growth, development, and pathophysiology. Dr. Bourne is a former president of the American Physiologic Society, Secretary General of the International Society or Union for Physiological Sciences, former editor-in-chief of Physiologic Reviews and Physiology. He authored and is the senior author for now in the 3rd edition, a book which you should all read, Medical Physiology, which we use as a core for our master's program, which he also initiated. And I should point out that he was elected to the National Academy of Medicine in 2014. So, Dr. Bourne, please join us.
Thank you, Stan, for the introduction. Good afternoon. It's a real pleasure to be with all of you this afternoon to honor Xin Shi being invested for the Silber Chair. So, from the point of view of a chairman, the most important thing you can do is to recruit and retain outstanding faculty. And so nothing could make you happier than when a young applicant is identified by the department and then recruited to come to the city of Cleveland, and then you as chair get to watch the wonderful process of a young faculty member blossoming to become an internationally renowned scientist. And this is she's still a very young scientist, and this is still early in their career. And so we're so happy to have her here in Cleveland. But it almost didn't happen because Xin had a previous career. It's very rare that one is here in the area of academia runs into a scientist who previously was a professional athlete. So it turns out Xin was a professional basketball player in China. And perhaps if she had been another foot taller, we never would have been blessed with her presence. But as it turns out, she had a change of heart and decided to shift to academia and got a bachelor's and master's degree at Shenyang University of Pharmaceutical University in China, and then picked up stakes and moved to Japan to get her PhD at Hokkaido University in 2005. She then moved as a postdoctoral fellow and then as a higher level postdoctoral person to Stanford University, working with Daria Mockley-Rosen. And that's when she was applying to become an assistant professor. And we were so pleased to have been able to recruit her to Cleveland as an assistant professor in 2011. She rose through the ranks to become an associate professor and then full professor at Case Western Reserve University, and now is the co-director, along with Jason Mears, of the Center for Mitochondrial Research and Therapeutics. In the laboratory, we have a snapshot of Xin looking at some scientific data, evidently from the smile on her face. She must be pleased with the data. Along the way, she's achieved several honors, including from the Falk Medical Research Trust, a Catalyst Award from 2017 to 2018, and then the Full-Fledged Transformative Award from 2019 to 2021. She's a Harrington Rare Disease Scholar, a Vinnie Scholar for Alzheimer's disease from the Harrington Discovery Institute. She received last year the Faculty Distinguished Research Award and was the John Deacoff Award for Excellence winner in graduate mentoring here at Case Western Reserve University. So she's been a scholar and an educator all rolled into one. Another snapshot, deep in thought. I'm guessing that perhaps she was not so pleased with these data. Well, she'll have to tell us. Along the way, Xin, as you'll hear, has become a world-renowned expert in the area of mitochondrial, she calls it cell biology, I think it's cell physiology, and has learned how the mitochondria operate and how to take advantage of what she's learned in the basic sciences to treat neurodegenerative diseases, which we'll hear more about from Xin. So without further ado, I'd like to introduce Xin Shi.
Good afternoon. Thanks, Walter, for this great introduction. It's a great honor to be here as a Janet Joseph Silber Professor for Brain Science. And I'm deeply grateful to the Silber family for their support, which inspired me to push the boundaries of brain sciences. Neurodegenerative disease affects millions worldwide, and yet effective treatment remains elusive. what if targeting mitochondria could be that solution? Today, I want to take you on my scientific journey, how curiosity led to mitochondrial research, how that path has driven the discovery of a therapeutic order. I was born and raised in Shenyang, China, and my father is a surgeon. So he dedicates for almost 40 years to medicine. And my mom is a civil servant, kept the family grounded while my dad has been always busy for his demanding work. My younger sister chose a different path, and she became a lawyer. So now, through single stage of my career, my family has been the greatest source of strength, inspiring me to pursue my career and to make a difference. And with that foundation, and let me take you on my scientific journey. So from the start, my research always been disease-driven, looking for solution. And this is largely influenced by my father because he has great passion for medicine. So I began at the Shenyang Pharmaceutical University, and this is a university in my hometown. And also, I actually, like Walter mentioned, I'm a professional basketball player. I'm also the captain of this women's basketball team in my college. So. But there, I actually studied cardiovascular disease. But from my PhD so in Japan and my postdoc training at Stanford, my research actually switched to neurological disorder. I'm going to tell you more about this. In 2002, I actually started my PhD at Hokkaido University in Japan. Under Professor Yasuyuki Nomura. On day one, he set 2 clear expectations: graduate in 3 years, do oral defense in Japanese, even though I did not speak that language. No kidding. So with that 2 expectation, I started my PhD journey there. And I studied the protein misfolding in the endoplasmic reticulum and their role in the brain ischemia. And I also actually explore if chemical chaperones can reverse the misfolded protein and reduce the brain injury. So luckily, 3 years later, I met my professor's expectation. He was extremely happy. So, but I think more importantly, what I learned from my journey is that we are capable of far more than what we thought. So with that experience, in 2005, I actually come to US and started my postdoc training at Dario Rosen's lab. And I have to say my postdoc training is the turning point of my scientific journey. And at Stanford, I learned how to think big, how to actually tackle translational strategy, and how to become an independent scientist. So Dario's lab studied protein kinase. Protein kinase actually with the distinct the role in many diseases. I clearly remembered our first conversation. She actually showed me this figure. And so this is the data showing that the delta PKC inhibitor protects the brain and extended the lifespan of the rat with the severe hypertension. And she actually looked at me and said, "Shin, I know this is the inhibitor protects the brain, but I don't know why. You will figure this out." So this is my first postdoc project. And also that was Daria's style. She actually fostered independency. She actually encouraged and most of the time challenged her trainee to think critically with the freedom. So actually through this project, I discovered that delta PKC inhibition preserves blood-brain barrier by regulating the tight junction component in the microvasculature. And that's why inhibition of a PKC could actually protect the brain from hypertensive brain injury. While I was still deep into this kinase signaling and unexpected observation in mitochondria, that completely actually redefined my research track. in 2007. While I analyzed the electron microscope image of the diseased rat brain, I noticed something unusual. The mitochondria were divided fragment with many actually appearing damaged or even empty. I showed this is the image together with many others, actually to Daria, and we were both intrigued, and we all curious about what was happening on mitochondria in this diseased animal. So this single observation sparked my curiosity. So that also actually led me to switch my research entirely to mitochondrial biology and the pathology with the great support of my postdoc mentor, Daria. So that was also the moment that laid the foundation for my lifelong research on neurodegenerative disease and the therapeutic development. Mitochondria are powerhouse of the cell and generating more than 90% of energy. They actually constantly fuse and divide. However, in a disease condition, this balance is disrupted and leading to excessive mitochondrial fission, and this causes the accumulation of damage in the fragmented mitochondria. This is highly related to the dysfunction of this organelle. So in the stress neuron or cardiomyocyte, you can clearly see the difference of mitochondrial morphology. They are dot sphere-like a staining pattern. This is what mitochondrial fragmentation look like in the diseased cell or the stressed cell, which is quite different from the one in the healthy one. More importantly, impairment of mitochondrial dynamics and associated mitochondrial fragmentation are early and prominent phenotypes in many, many human disease, and including neurodegenerative disease. So actually, we are using different samples and the model system. We observed the massive and actually mitochondrial fragmentation in the neurodegenerative disease models prior to neurodegeneration. Because of this common mitochondrial phenotype and also the importance of mitochondria in human disease, then we actually curious if blocking this process could be useful strategy to treat the disease. So it's known that the mitochondrial fission, a protein-protein interaction between DRP1 and FIS1 drives mitochondrial fission impairment and the stress or diseased condition. So we actually use the advanced screening system and discovered a peptide called P110 that specifically block the protein-protein interaction between DRP1 and FIS1, especially under stress or disease condition. So over years and our own lab, many of my collaborators and even many other independent investigators have shown this peptide protection in numerous human disease models, and including neurodegeneration. And I'm so happy to know that the P110 is already under clinical development. So I think this is when I actually look at what should I actually present today, I actually think about this is a really good example to show the scientific discovery process from curiosity to disease mechanism to therapeutic development and even later translational research. So over the past 14 years, my lab still focused on mitochondrial dynamics research by discovering the novel regulatory factor. But we did not stop there. We actually expand our research scope to a different angle of mitochondria. They call it mitochondrial quality control with a new concept. We try to understand how mitochondrial protein folding and the misfolding drives the protein aggregation in the numerous neurodegenerative disease, which is a featured pathology. And we also consider mitochondria is a social organelle, communicating with a neighboring component such as ER, nuclear, lysosome, and also serve as the immunohub, communicating with the immune response. There's a quality control mechanism actually based on our study and many other studies actually show that actually they play an important role in initiating and progressing of neurodegenerative disease as listed here. So with that knowledge, we actually developing mitochondria target therapy. So far we have developed 3 peptide regulators targeting mitochondrial quality control, and also one small molecule called mitochondrial enhancer to actually improve mitochondrial capacity in a variety of human disease. In the collaboration with industry partner, now we are working on translating these scientific discoveries into the potential therapy that could prevent or reduce the neurodegeneration and all other human disease. So scientific process is not a solo endeavor. So I'm so happy and so fortunate to work with many young talent and creative and hardworking scientists. So they are passionate on science, they are hardworking, and the creativity really actually drive our research, move forward. And also, I believe collaboration and actually drives innovation. So over a year, I'm so happy and so grateful to collaborate many outstanding investigators across the discipline, and ranging from the biomedical informatics, the neurodegeneration and drug discovery and technology development, biochemistry, chemistry, and also mitochondria with a new different aspect. I have to say I'm so grateful to the collaborators. Their expertise and the insights actually really drive our research. Beyond the research, and mentorship and the leadership have been integral to my career. I want to thank Dr. Boron for his support. He recruited me to Cleveland, and he actually supported me and guided me from the day one. He always encouraged me to look bigger picture. I want to thank my mentoring committee, George, Chuck, and Dave, and their guidance and the support have been instrumental. They have supported me actually go through this toughest stage of the junior faculty. And so I especially also want to thank my colleagues in the physiology and the biophysics and the Center for Mitochondrial Research and the Therapeutics for their fostering the collaborative environment. I'm really enjoying working with them. And in addition, I want to thank Dean Gerson for his support and advocating for brain science and translational research. Again, special thank you to Silber family for their support actually driving the mission. So finally, I want to express my greatest gratitude to my family, my husband Eric and my son Evan. I have to say, without them, and nothing could be possible. And they have supported me and through my entire career. And I have to say, I really own them. And thank you to my family. And just want to share a little bit, and since my son went to college last fall, so my husband and I have been embracing this is a new chapter of empty nester with these 2 lovely kids, the girls. So today, as I stand here, I'm a little bit emotional, and I actually feel the gratitude for my mentor, my collaborators, my colleagues, my family, and my lab members, and so many people around. And I really appreciate the support and the guidance, and also somehow just insight through my career. Looking ahead, and so my mission remains clear. So to push the frontiers of mitochondrial research and also translate our discoveries into meaningful application that could benefit many people. And thank you so much for being the part of my journey, and thank you for your attention.
Surprise, I'm going to have you sit in your chair. I'm sure this is the right. Congratulations. Now, we don't normally get the opportunity, but I've asked Dr. Brady Calley to come up so I can get both of you sitting in your chairs at the same time. So I hope you appreciate how special this event is, not only that we have two chairs, but they're in related fields with donors that had a relationship, at least in the area of brain tumors. These are phenomenal, accomplished women, and I'm delighted to remind us all that since I've become the dean, 43%, now two more, of our professorships have been to very deserving, creative, and ingenious women, and I hope these two carry on our efforts in brain research for decades to come. So thank you all. And we have refreshments for further conversation outside. Thank you.